FE Patil. In last video we discussed about the first method, that is polarization by reflection. Now in this video we discuss about the other methods which is used to produce the polarized light. So second method, that is polarization by refraction. Polarization by refraction. So initially I will draw a diagram. This is unpolarized light. Now this is the transparent surface, that is glass surface is there. Okay. Now when light is incident on this glass surface, a part of light will be reflected and part of light is refracted like this. Again, the light will be from the surface, the light will be reflected, refracted like this. Finally, the light will be emerge out and we get plain polarized light. Okay, this is nothing but the piles of plates. The piles of plate means what? Instead of one glass plate, if we use number of glass plate and they are mounted one over another with a small air gap between them, called as a piles of plates. Understood? So this is the piles of plates. Okay. Now this is unpolarized light. This is partially polarized light. This one is plain polarized light. Okay. Now I will explain. So when unpolarized light is incident on a transparent surface, then a part of light is reflected and part of light is refracted. The reflected light is known as a plain polarized light and refracted light is called as a partial polarized light. Okay. Now again at each surface the light will be reflected, refracted, reflected, refracted. And if we use, instead of one glass plate, here we use number of glass plate, and due to this reason the process is repeated and we get the unpolarized component decreases and polarized component becomes prominent, and which gives almost a plain polarized light, and that plain polarized light is parallel to this piles of plates. Understood? I will explain one more time. Here unpolarized light is incident on a transparent surface. A part of light is reflected, called as a plain polarized light. A part of light is refracted and called as a partially polarized light. Here, instead of one glass plate, if we use number this reason, the process is repeated and hence unpolarized component, that is perpendicular component, decreases and polarized component becomes prominent, which gives plain polarized light which is parallel to the direction of the piles of the plates. Understood? So this is about the polarization by refraction. And always keep in mind, this piles of plate contains 15 glass plate which is placed in a metal tube. Understood? So this is about the polarization by refraction. Very simple method is there. Unpolarized light incident on a transparent surface. A part of light is reflected, part of light is refracted. Here in this method we use number of glass plate. So due to this reason, at every surface the light will be reflected, refracted, and due to this reason unpolarized component, that is perpendicular component, decreases and polarized component becomes prominent, which gives completely plain polarized light which is parallel to the direction of the piles of the plate. So this is about the polarization by refraction. Now next method, that is double refraction. This is also very simple method, double refraction. Now the double refraction phenomenon discussed or was discovered by the scientist Bartholinus in 1869 during his studies on calcite crystal. Means the scientist Bartholinus was discovered the double refraction during the year 1869, and in his experiment he used the calcite crystal. Understood? Now I will draw a diagram. This is unpolarized light. Okay, unpolarized light which is incident on a calcite crystal. This is the calcite crystal. It makes an angle of incidence I, and when that light enters into the calcite crystal, it produces the two refracted rays. If we consider this is A, this point is B, this is C, this is D, E, F. So one is along BC, make an angle R2, one is along and other is along OD, make an angle R1. Okay, now this is extraordinary ray. And this is ordinary ray. So listen carefully. The scientist Bartholinus during the year 1869 was discovered the double refraction phenomenon. In his experiment, Bartholinus used the calcite crystal. So when unpolarized light incident on a calcite crystal, then it is found that it produces the two refracted rays. One is along BC, other one is along BD. These are the two refracted rays having or which is in different properties. That is, both rays have different properties. Okay. So the phenomenon of causing two refracted rays by the crystal called as a double refraction. Okay. So one ray which obeys Snell's law of refraction Snell's law of refraction, then it is said to be an ordinary ray or O ray. Understood? And the ray which does not obey Snell's law of refraction, then it is said to be an extraordinary ray. Okay, so one more time I will explain. Now in this, if we see this figure, then it is observed that when unpolarized light AB is incident on a calcite crystal, then when light enters into the calcite crystal, it is found to produce two refracted rays. One is along BC, make an angle R2, and other is along BD, make an angle R1. So the ray which obey Snell's law of refraction called as an ordinary ray, or we can say that O ray. Then the ray which does not obey Snell's law of refraction, it is said to be an extraordinary ray, or we can say that E ray. Understood? So this is about the double refraction. Okay. Now next